Good day all and welcome once again to my YouTube channel. Today we are going to be looking at a topic in chemistry called stoichiometry of reactions. Now many students when they hear of calculations involving chemistry, they are usually scared of it. Why? Because maybe they don't really have much foundation or probably their approach towards calculations involving chemistry. But let me just tell students out there that calculations involving chemistry is not difficult. The only thing you do is this: have a proper approach towards it. Don't be scared of it. Give your best to it. Love it. And then you get to understand that that area in chemistry is a very, very interesting area. Considering stoichiometry, that's one of the aspects of chemistry that deals with calculations. And looking at the calculations of stoichiometry, some students may be wondering that this thing is a very, very difficult stuff, but it's not. Now, I'll be running through the series of stoichiometry with students, so you just follow through and then you get to understand quite a number of things about stoichiometry. On the board, we are having some important terms that are associated with stoichiometry, and we have the mole, we have mass, and then we have molar mass. Now, if you are able to understand these terms that are associated with stoichiometry, you won't be having issues with stoichiometry. So looking at the introduction to the world of stoichiometry, we are going to be having a series of videos on stoichiometry, of which this is the first video. That's the introduction to the world of stoichiometry. Now we are going to look at these terms that are very, very important in the world of stoichiometry for you to understand the introduction to stoichiometry. Because if you can understand the foundation of stoichiometry, then you won't be having issues with other aspects of stoichiometry, especially the calculations. Now, when you hear of stoichiometry, these are terms that are associated with stoichiometry: mole, mass, and molar mass. And interestingly, these terms are connected by a formula. But meanwhile, let's get to know what each of them represents. Now, looking at the first one, mole. What is mole? Mole is simply the actual amount of a substance which contains as many particles as there are in 12 grams of carbon 12. Alright? Now, looking at that definition of mole, I will explain in detail, but you just take cognizance of that definition. That is the definition of mole. Then for the definition of mass, mass is simply the actual weighted quantity of matter that is contained of a substance. Meaning that when we talk about mass, we are referring to the actual weighted quantity of matter that is present in that substance. Alright, that is the definition of mass. Then looking at molar mass, from even the word molar mass, it means the mass of 1 mole of a substance. The mass of 1 mole of a substance is what? Molar mass. Many students, they don't know the discrepancy between mole and mass. Oftentimes, in some texts, they can be used interchangeably. But then again, it's not really appropriate because let me explain the discrepancy between mole and mass. Take for example, this is a marker, just one marker. Now, if we place this marker probably in a triple beam balance or probably in another weighing machine, we can get the mass of this marker, just one marker. One marker. Now, the mass when weighed in a beam balance can be, let's say, 20 grams. So this one marker weighs 20 grams. So can I say that the 20 grams is the mole of the marker? No, it is actually the mass, because grams is the unit of mass. So this 20 grams is actually the mass of this marker. Then while the one there signifies 1 mole of the marker. You get the point now? So it means that just 1 mole can contain the mass of the substance. So that thing that is being contained in that 1 mole is considered to be the mass. Then while the one itself is considered to be the mole. So you could be having 2 moles. So if 1 mole of, let's say this marker weighs 20 grams, then two markers will weigh 40 grams. You get the picture? So that's just it. So now you see the discrepancy between mole and mass. There's a relationship that connects these three. By a formula, you are going to be having number of moles. Number of moles is given as mass over molar mass. You can find this in most textbooks as to be the formula that connects number of moles, mass, and molar mass together. Mind you, number of moles of any substance is measured with a unit, mole. Then while the unit of mass is measured in grams. Then while the unit of molar mass is measured in gram per mole. Alright, you know that the abbreviated form of this should be G, which is grams. So then again, what is now the formula that is now connecting them? It's written on the board. Number of moles is equal to what? Mass over molar mass. And don't forget, the molar mass of a substance is simply the mass of 1 mole of that substance. Again, 1 mole of any substance is equivalent, or it contains about 6.02 times 10 raised to the power of 23 particles of the substance. So 1 mole of any substance contains 6.02 times 10 raised to the power of 23 particles of that substance, meaning this value is considered to be called the Avogadro's number. The Avogadro's number. Alright, that's 6.02 times 10 raised to the power of 23. Now, looking at that value, it means that 1 mole of any substance, be it an element or a compound or a gas, is equivalent to this. So if you are now asked, 1 mole of oxygen molecule will be equivalent to be 6.02 times 10 raised to the power of 23 oxygen molecule. If it were to be 1 mole of oxygen atom, then it would have been 6.02 times 10 raised to the power of 23 oxygen atom. So atom to atom, molecules to molecules. And please, you must understand this clear concept, the discrepancy between an atom and a molecule. What forms a molecule are atoms. Of course, a molecule can be simply defined as a substance that is made up of at least 2 atoms. It could be atoms of the same element or of different elements. When it is atoms of the same elements, then you can go with the umbrella name elements. For example, if you are having O2, this you can call oxygen molecule. Why? Because in this, you are having 2 atoms of oxygen. And like I said, a molecule is made up of at least 2 atoms. So these atoms now, they are of the same element, oxygen. So you can go with the umbrella term element. So this still remains element, irrespective of it being a molecule. Alright? Because you know that the atoms that form the molecule here, they are atoms of the same element. Then look at this one, CO2. Now this one, you are having 3 atoms there, 2 atoms of oxygen and 1 atom of carbon. So in this case, since the atoms are of different elements, then you can simply go with the umbrella term compound. But that doesn't stop this from being called a molecule of CO2. The reason is because it is made up of at least more than 2 or more atoms. You get the point? So this is a molecule, this is also a molecule. So what does that mean? A molecule could be an element or a compound. When it is an element, it means it is actually made up of atoms of the same element. But when it is a compound, then it simply means that it's made up of atoms of different elements. So you tend to understand these concepts very, very well about stoichiometry. Now, let's see another thing about stoichiometry. Now, you must have seen this before. You are having A here, and you are having Z of an element X. Now, sometimes they will represent this in textbooks and write, let's say 31 here, and let's say you are, or let me just write 24 here, and let's say here is 12. Usually, they will call this atomic number and call this in some text atomic mass. And in brackets, they will now write mass number. Now listen, many students believe that another word that can be used in place of atomic mass is mass number. but that's not really appropriate in a way, though they are similar but not exactly the same. Now, looking at this atom X, so the interpretation of some students would be that this 24 is actually the atomic mass or the mass number of atom X, and while the 12 is the atomic number, or you can still refer to this as proton number of atom X. Now, for the atomic mass, pay attention to this. Atomic mass is not really mass number. The only similarity about atomic mass and mass number is that they are both having the same numerical value. But in terms of the discrepancy between both of them, mass number is simply an ordinary number. What constitutes or what makes up mass number is by the summation of proton number plus neutron number. So when you sum up the proton number and the neutron number, it gives you the mass number. So it is an ordinary number without a unit. But in the case of atomic mass, it has a unit, and the unit of atomic mass is AMU, which is atomic mass unit. So looking at this atom X, let me clarify that. If you are asked what is the mass number of atom X, you can say it is 24. Then if you are now asked what is the atomic mass of atom X, then you can say it is 24 AMU. Observe it, they are having the same numerical values but with a difference. And what's that difference? One has a unit. And which one has the unit? The atomic mass. Alright? Then now, you can also replace this again with Daltons. Of course, AMU is equivalent to Daltons. So if I write 24 DA, it's still same as 24 AMU, because one Dalton is equivalent to 1 AMU. All right, that's atomic mass units. All right, so please note the discrepancy between these stuffs. All right, so this is actually the introduction to the world of stoichiometry. In our next video, we'll be looking at calculations involving stoichiometry, dealing with the mass to mass relationship, the mass to volume relationship, the volume to volume relationship, and all that. All right, so please just stay tuned as we run through the series of stoichiometry. Thanks for watching, and don't forget to subscribe, share the video, invite your friends to this YouTube channel so that for them to benefit as well. Thanks for watching and remain blessed.